Sketch and compare f of x equals to x cubed and g of x equals to negative x cubed. We're now learning how to do reflection of a cubic, and just having a look at this graph, this is roughly what it will look like. This is the base graph, which is our usual y equals to x cubed, and this is the reflected graph that you get by putting a negative in front of the x cubed. What we say about this is that the graph of x cubed was reflected in the x-axis, because you can see that the x-axis can act like a bit of a mirror, and your part from up here gets mirrored and appears down here. So it's like mirrored and appears down there, as you can see. And same happens with the left part. It's down here and it gets mirrored and appears up the top. So you can see that top bit appears. So it's looks like it's reflected in the x-axis. However, for cubics, it's actually the same if you reflect it in the y-axis as well. If you mirror this across that way, it also appears here, and same happens with that. If you mirror that, it appears down there. So technically, the reflection can happen in either axis and it's still equivalent, but for convention, because the negative is outside, we say that it's reflected in the x-axis. Okay, so let's go ahead and try to draw that. Now, we've already looked at how our cubed, regular f of x cubed looks, and I'm just going to go through and fill these in. So to get from x to x cubed, you just put it to the power of 3. You do x to the power of 3, and that will give us our y values for the regular graph. So let's just quickly do that. So negative 3 cubed is negative 27, negative 2 cubed is negative 8, negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. Okay, so let's try to draw that on our graph. These are our x values and these are our y values. So I'll start with the origin 0, 0. That's where our point of inflection is. Then we'll have a point fairly low along, which is going to be the point 1, 1. One step across, we have the point 2, 8, so it's quite a bit higher. And then one more step across, it's way, way higher because it's up to 27, 3, 27. I keep mixing my 2s and my 7s. 3, 27. Now, in the negative direction, we have the same sort of thing happening. So for negative 1, it goes to negative 1. At roughly, negative 2, it goes down to approximately negative 8. And then negative 27 for negative 3, it's quite low down, maybe around here. Negative 3, negative 27. Now just connecting those, remember curves over for the bottom part and curves a bit under for the top part, we get this sort of cubic. I'm just going to make this a bit more curved so it's a bit more obvious that there's a curve there. That doesn't look too bad. So this is our f of x equals to x cubed graph. All right, now let's work through the reflected version. So you'll notice that the only difference between f and g is that there's this negative in front of the x cubed. So to get from the f values to the g values, all you have to do is multiply it by negative 1. So let's go ahead and do that. Negative 27 times negative 1 cancels out the negative and leaves positive 27. Negative 1 times negative 8 gives 8. Negative 1 times negative 1 gives 1. 0 times negative 1 is still 0. And now since we're up to the positives, they will become negative. So 1 times negative 1, that acquires the negative. 8 times negative 1 gets to negative 8. And 27 times negative 1 turns into negative 27. Now let's have a look at how these coordinates end up. The very first one on the left, we're starting with, for f of x, we had the coordinate, it was negative 3, negative 27 for that first one. But for g of x, now we still have negative 3, but it's turned into positive 27. So we'll match up the x value of negative 3, but instead of being all the way down here at negative 27, it's actually going to be the same distance up, and it will be positive 27. So this coordinate will be negative 3, positive 27. And the same thing happens to the rest of the negatives. We had negative 2, negative 8, which we said was around here, but now it's going to be positive 8 at the same x value. So we'll go to where our positive 8 was. It's going to be about here. Okay? Negative 1 and 1 does the same thing. It's going to end up approximately there. Now it still goes through 0, 0, so we'll know it still goes through the origin. And for the positive x values, it's going to have the negative y values. So we have positive 1, instead of being at positive 1, it's positive 1, negative 1. So down here, we have 2 comma negative 8. So from 2, we go down to negative 8. And from 3, we go all the way down to negative 27. So around here. 3 comma negative 27. Okay, now let's connect the dots. This time the curvature is going to be swapped. So this part curves upwards. So this part curves, downwards, similar to how this part curved before. And this one will curve over like that. All right, so I'll just label this one quickly. This is the g of x one, which is the reflected graph, negative x cubed. And if you have a look now, you'll notice why it's called a reflection is because all of our points from the bottom got reflected up to the top, and all of our points from the top got reflected downwards. So it's as if it was reflected in the x-axis. Okay, so there's your reflected graph of the cubic.